So a little bit of a recap from yesterday. We talked about how sometimes we need to modify the shape of our data. And we have two really helpful functions for that, pivot longer and pivot wider. So pivot longer takes our wide data, makes it long. We'll see that this is really helpful. We saw this a little bit yesterday too, for making data visualizations and sometimes also for data analysis. And so we had a couple of arguments, names2 and values2. Names2 gives the new name of pivoted columns, and values2 gives the new name of the values that used to be in the columns. Pivot wider takes our long data and makes it wider. And we have names from and values from. So they're really parallel structures. And it specifies the old column name that contains the new column names that will become the wider column names. And it specifies the column that has the values that will become the values in the columns. We also talked a little bit about merging and joining data sets together and that they need a variable in common. So in our lab, we had a country variable. And we learned that there were many different ways of joining our data. We talked about inner join, which only keeps things that are matched to that ID for both data sets. Full join, where we keep everything from both the X and Y data sets. Left join, where we prioritize what's in the left side of our parentheses, so the X here in this case. And so everything is kept from X, even if it's not in Y. We just fill those in with NA values for the Y columns. And right join does the opposite. So it would preserve what's in the Y object here. Anti-join does something very different. It only takes the rows from X that are not in Y. And so that can be helpful if we want to see what names or what IDs are unique to a particular data set. So we can see what in X was unique to X and not in Y. And then we saw how the esquisse package has a function called esquisse-r that can help us make sketches of plots. And so the R community does this really nice thing where they make hex stickers for different packages. You may have noticed on Slack, I have like a patterned thing behind me in my photo. I'm actually standing in front of a bunch of hex stickers. So the esquisse package indeed looks like a sketch, like it's intended to be for our graphs. And then today we're going to talk about ggplot2, which is, when we're really making our plots and we're ready to refine them. So since you can do a lot with esquisse, why do you even need to learn about ggplot2? Well, sometimes we need to do additional customization, and we'll see that with more complicated data sets, things will get a little bit, they just won't be optimal for the data that we're working with, and we'll want to do more customized things. We'll also see that we can do branding, we can make plots interactive, we can combine plots together, we can automate the creation of plots in our scripts more easily. And eventually, when you get really used to ggplot2, it can actually be faster than working with esquisse because you have to go to the GUI and do all of that. And so, I have lots of plots that I've made for various projects. And I remember, I did this really fancy plot for this thing. It was kind of unusual. I'm just going to go take the code and adapt it for what I'm doing right now. So ggplot2 is kind of an unusual name. The GG stands for Grammar of Graphics, created by Hadley Wickham, who's probably the most famous person in the R community, and it's part of the tidyverse package. So when you load the tidyverse, you automatically have the ggplot2 package, and you'll hear people say, make a ggplot, and they're referring to use the ggplot2 package. So it's really quite popular and well-known because it's extremely powerful. So there are a couple of resources here for additional information about how to make fancier visualizations. Okay, one thing to get out of this would probably be one of the main lessons of today, is that ggplot2 plots are made with layering. So we layer different aspects on top of one another, and we combine them with this plus sign. So we've been using a pipe, we've been using commas. In the case of ggplot2 for individual statements, we're going to add those layers with a little plus sign. And it's a little bit like a recipe. So the initial part of it might feel a little counterintuitive. We always start with the ggplot function, And then we have to specify the ingredients that we're using. And that's going to be with an aesthetic function called AES. So it's standing for aesthetic. And then we can add on other fancier layers to make it visually appealing. So again, it's extremely powerful. It's extremely popular. Even people who work in other languages will sometimes just use R to make visuals. There, however, is one drawback, which it is that it's a little bit counterintuitive, which is why Esquisse is really helpful because it gives us kind of a leg up on getting started with our plots. There's a really useful gallery here, which will take you to a bunch of different ways in which other people have used ggplots and all the different kinds of ggplots that you could make. I don't know why this is so large in font. Anyway, you can see, here's an example of some plots here. And it has the code. It has lots of suggested different types of plots that you could use for different kinds of data. So I suggest you check that out because it's really helpful. And so before we get started with plotting, it's really important that our data is ready for it. So indeed, we have to have the right shape, but also our data needs to be what's called tidy. And we've been working up building to this because we've been working with all these tidyverse functions to get into a state to where our data is ready and is in this tidy format. So to have our data be tidy, each variable needs to be its own column. So if anything's combined together, we would have already used the separate function. And each observation forms a row. So when we have messy data, we might have column headers that are values. They're not actually variable names. We might have multiple variables stored in one column, or variables that are stored across columns and rows, and we need to reshape things. So here's an example of some data here where we have actually some data nested inside of our column names here. So they're actually values instead of variable names. They're ranges of incomes for different populations of people who have different religions. And if we make it tidy, we would then make it in long format where we have the income variable as something that we can actually call in our code for graphing. It would not be as possible when it's across the variable column names here. All right, so let's try to work with some data ourselves. We're going to be working with the Colorado heat-related ER visit data that we've been working with already. And we're going to subset it just to make it a little bit simpler. And by doing so, we're going to specify that we only want the county that is exactly equal to Boulder. So remember, in filter, we need to do exactly equal to if we're trying to look for a very specific value. And anytime we have a value, we need quotes for that because this is a character string and not a column name. So I'm going to run that over here in our studio. Actually, I'm going to run this twice. I'm going to clean this up. A little too hectic over here. And make sure I have all the packages I need. All right, so we now have our ER Boulder data. So every county here is going to be Boulder. We've got our rate of visits, our confidence interval, the number of visits, and the years. All right, we're going to make our first plot. Woo-hoo. Okay, so like I said, the first thing we have to do is figure out what our ingredients are, and that's going to be with that AES function, and that's going to be inside our ggplot function, which is just the base of our plot. So you kind of think of this as the base of our cake. So in the aesthetic mapping function, we specify what data is going to be where. So are we going to have an X and Y axis? What data in our data object is going to be used for X and what is going to be used for Y? You might see a mapping argument, which is not required. Some people use it. It's inside the AES function, but it's kind of unnecessary. So this is the general format here. You specify the data that you're using. You need to use that AES function, and then you specify what's going to be X and what's going to be Y. You might even see people not put the X and Y argument and just rely on the order, but it's helpful to see exactly which axis we're trying to plot. So does anyone notice anything strange about this plot? Yeah, that's right. There's no points. And that's how all of our ggplots start out. Yeah, so we can see our y-axis and our x-axis is now mapped to our plot here, but it's not a very exciting plot, so we need to do some more. And so to do that, we add the layers to our cake, and these are specified by geom_ functions, and there are a lot of them. So similar to how we looked at different functions for stringer, we could look these up like so. There we go. We could type in geom and we can see that there are so many possibilities. And if we're curious about what they look like, remember we can use that gallery that I showed you. But there's really, I would say, about under 10 that are most commonly used. So geom point makes a point plot. That's what we've seen in some of our skis plots. Geom line has a line plot. Box plots, histogram makes a histogram, bar makes bar plot, column makes a column plot, and geom tile makes blocks filled with color. So I think these are the most commonly used plots, and we've given you some examples of when to use what kind of plot. And of course, if you have a particular unique situation, then you might need something else. And again, that gallery can be really helpful to figure that out. But by and large, these will cover you for a lot of what you need. So the geom point is really helpful for trying to examine the relationship between two sets of continuous numeric data. So meaning data that has that double precision. Maybe it's an integer, but it's not ordinal data where it's a number specifying necessarily categories or something like that. But it's something that we can plot easily on our X and our Y and make a point plot, a scatter plot easily. So we're going to be seeing a lot of examples of that. Geom bar is helpful for comparing groups or categories. So if we have some numeric data about data that's categorical or character type, then it's a really good option. I prefer geom box plots, however, because they're a little more informative than geom bar, but a lot of people use those. And then histograms are great for trying to understand the distribution of some numeric data. Okay, so let's make our plot a little more exciting. We're going to use that plus sign to add a layer to our plot. And the general format here is just any type of geom. The plus sign has to be at the end of each line. If we put it at the beginning of the next line, R will not like that. So try to remember that it needs to be at the end of the line here. And so if we add geom point here, we can see we finally have something plotted on our plot. So it's getting more interesting. And I'm going to show how it looks like when we don't put it at the front or at the end. It gives us an error. Cannot use the plus sign with a single argument. Did you accidentally put it on a new line? So it gives us pretty helpful information here, which is nice. Much better. Okay. So now we're starting to get a sense of how consistent the data is, the range of the values, etc., how they've changed over time. So again, reminder here, not to have the plus sign in the front of a line, but also you cannot use a pipe. That will also throw an error. Try that. It'll say, did you use a pipe instead of a plus sign? So helpful error messages. They're not always helpful, but these ones are pretty helpful. And you can also save a plot to be an object, which is great because you can reuse it for later steps. So in this case, we're just assigning it to something called plot one. It can be anything you want to call it. So I'll call it plot one this time, written out. And you'll notice I don't print the plot. Just like anytime I assign an object, like a data object, I'd have to actually write out the name of the object to see it, but I can see it in my environment here. It shows up as a list. And when I run this again and I actually have it listed here, I can see it preview in my R Markdown. If I want to see it show up in my plot pane, I need to write it down here in the console. And that can be nice if I want to zoom in, I want to export, etc. So there are, again, lots of different geoms. Another geom that might work for this data is geom line. And the difference here is that we draw a line between the various data points. And we can also save that to an object. And again, I'd have to call it to be able to see it. Sometimes it'll do this where it doesn't seem to be previewing anything. I might have to do it twice and it'll show up. And I can scroll through the different plots here. Similarly, if I do it down here and I do plot 1 first and then plot 2, I can scroll through my plots like so with these arrow buttons. It can be helpful to compare, or did I like that plot that I just made? Is that better? So that can be useful. We can actually layer different geomes on top of one another. So we can combine geome point and geome line. And so the geome line is just drawn on top of the points here. All we need to do is use that plus sign and make sure it's at the end of the line. All right. So let's try doing some more exciting plots here. So I'm going to filter county for 4 specific counties. I'm going to start with the original data here because I want something more exciting than just Boulder, which is what we previously had. And I'm going to be plotting some color this time. And I can simply add color inside the aesthetic function here. And that's kind of a tricky part, is that I have to specify it here in the aesthetic if I want to map it to a variable. So remember, aesthetic is where we map each of the variables to the different features of our plot. So we're mapping county to color. So when I do that, all of this code is the same, geome point, geome line, etc. Then it takes what my original plot was and splits up the data by county. So let's take a look at that, and we'll see the difference between adding color and not adding color. So in this case, I'm filtering for a number of different counties. So that's when I'm going to want to use that in operator. I could use exactly equal to Denver or exactly equal to Weld, but that would be more code. So this is a faster way of doing that. And I'm going to compare this to a colorless version. And again, it kind of got stuck, so I'm going to press it again. All right, so here's our colored version. Looks really nice. I can see my different counties. I can see what color corresponds to what county. And this one looks a little bit strange. So we'll talk more about that. But, sometimes you might encounter this. And when that happens, you're going to want to add a color option. All right. Beyond adding color, we can customize the look of our plots a lot. And the major way that we do this is with a theme function. So if you click here, it'll take you to a library of different kinds of themes. It describes what's happening with that, like the size of the font, things like that. And it describes what they kind of look like theme dark is the dark cousin of theme light with similar line sizes, but dark background. And then you can see a preview of what the different styles look like. And so all we have to do is take our plot object and add a plus sign, or use the plus sign with the theme to our code that we're using to write our plot. So in this example, we've added theme dark. We've also added some other aesthetic arguments here, like color alpha, which has to do with the transparency. So transparency of 1 means it's not transparent at all. I think that's the range of it. Typically, a fraction is less transparent, or semi-transparent, and that's what you often want to use. And then a line type can help us change the type of line that we have. And we'll see we have included in the slide the different types of lines that we can use. But the major point here is that even with just this, we can change the aesthetics, but we can do more specific things for individual layers as well. The size here is just specifying how big the points are and how wide the line is. So let's try something similar, but a little bit simpler over here. I'm just going to add theme. And look, if I type in theme underscore, I see a lot of different options. I'm going to try theme line draw. That's one of my favorites. And I need to add a geome layer. I'm going to do nice. And I can try a different one, theme dark. Here we go. And if I wanted to change the color of my points, I could do so like this. There's a lot of other themes besides the typical themes that come with ggplot2. We've given you a few options here. If you're interested, you can learn more about them. There's some fun ones. This package called Theme Park has themes related to pop culture. Okay, but good practice with plots, something super duper important is we have to have proper labels. There's a label function, labs, and inside of it, we can specify arguments like title, X, Y. X will be the X-axis, Y will be the Y-axis, and title will be the title. So here we've specified a title. We didn't have one at all previously. We just put little commas in between each of our statements, just like we would for any arguments inside of a function. And we do need quotes because these are characters, character strings. So notice that the x-axis becomes year and y becomes age-adjusted rate. If we look at our original plot, it's just going to put the variable names for those x and y axes, and it's not going to have any labels for the title. So say I just want a title, I can use the labs function and I can say, and notice here, it's suggesting things for me like subtitle, title, etc. And I'll say title equals my plot. Not a good title, but just for examples. And now I can see it here. All right. Another thing that's important to know about is specifying the x and y axis. And this is something that would be harder to do with the skis. So sometimes ggplot's going to automatically pick maybe not the best way of breaking up our data to show labels on these axes. And so sometimes we want to specify the way that they look. So in our plot here, we've got some weird year information, right? Like, I don't know about you, but I don't typically think about 2017.5 when I think of a year. I typically think of just the years, and maybe I'd have a point that's somewhere in between or something, but I don't say 0.5. So I don't really like that, and I would like to fix that. I can do so using the scale x continuous. I know that this is a continuous variable. It's numeric. And I'm working with the x-axis, so that's why I'm going to use that one. And doing that, I can specify the breaks here. So I could actually just write them all out, or I can be nifty and use my seek function, which will write them out for me. So remember our seek function. Just going to do this part alone by itself here. It has a from argument, a to argument, and a by. It would probably do this by default. Yeah. But, this is really clear about what we're doing here, but we're creating a sequence from 2011 all the way to 2022. And so I am essentially forcing the breaks for the x-axis to be what I want. So I could either do it this sort of shortcut way, or if I didn't remember about the seek function, that's not always easy to copy paste in R because of spacing. I could simply write out every year that I wanted. A little tedious, but I'll get the same results. There, the mistake. All right, nice. So now my grid lines are really helpful, I think. Each of them corresponds to a given year. So if I'm curious about 2014, I can really easily tell what the rate was in 2014. All right. You can also, simply add layers to change a plot and overwrite things. And we can reference an existing plot object to do that. So we saw this a little bit earlier, but, we could add theme minimal either to the plot the code that we're working on, or we can simply just add it to the object afterwards. So here I have theme dark up here. I could get rid of that and say plot 1, and then I can just simply say plot 1 plus theme to spell theme right though. Similarly, I could add other attributes like the labels or change the scale, etc. I will get into some trouble sometimes adding layers because sometimes it doesn't know what the aesthetic mapping is. So it tends to be good to add those when you're writing your code for the plot. But there's a lot of things that can be done afterwards. All right. And sometimes we don't want legends. In this case, I would probably keep it because I don't know what these colors are. But there are instances we'll see later where we don't necessarily want to keep a legend. And to do that, there's an option called theme legend position equals none. And I don't have a lot of good ways to remember this. It's kind of a specific thing. We'll learn more about where this is coming from. But for now, just realize that you can always Google, how do I get rid of the legend in a ggplot to get rid of it? And we can also add, like we saw, some specifications to the layers themselves. So I can make things different sizes, different colors that will only color one thing at a time. It will not have to do with the group where I've mapped it to a variable, but I can do some things with aesthetics inside my layers as well. We'll see more about that in a second. Okay, so we saw previously how we got a weird plot when we just did black here. So what is happening there? So we are overriding the country color here. If I remove this, you got to be careful with your color mapping here because you could overwrite something pretty important. Like this actually got rid of our lines in the right way when we tried to color the line black. But this makes sense kind of because if you think about it, R is sort of thinking like, wait, what? We have color for a line already. How am I supposed to color the line now? And it's going to use whatever the most recent layer has suggested. Okay, so in summary, ggplot specifies what data to use and what variables. So inside our ggplot function, we put our AES mapping here, and that's where we put our X and Y axes and any color specification for mapping it to a variable that we might do. To use a plus sign to add our different layers, that needs to be at the end of lines. If we want to change the overall look, we can use one of our theme functions, but we can also specify things for each of our individual layers, like size, color, alpha, transparency, and line type. You can add labels, the labs function for X, Y, and title, or even subtitle. And we can modify the scale of the axes with scale X continuous or scale Y continuous. Note that has to be for numeric data. And just so you know, ggplot will remove points from missing values from plots. And when it does so, it will throw you a warning when you're creating the plot, and it'll say, whoa, we dropped a bunch of values. And all it's saying is that you had missing data and it didn't know how to plot them. Okay, gut check here. If we get an empty plot, what might we need to do? Would we maybe need to add a plot underscore layer like plot point, or add a geom layer like geom point? The answer A or B. What was the name of the functions that we use to add layers? They all start with what? Correct. The answer is B. They all start with geom. And if I can't remember, I can look in the documentation and it will make suggestions for me. I can look in the resources that we've provided. I could look in the notes. I could look at the cheat sheet. How do we add layers in ggplot2 plots? Do we use a pipe, an and sign, or a plus sign? Very good. Yes. Plus sign looks like this. It has to be at the end of our line.
So we'll want to go ahead and see, we're loading some data up first. So just making sure we run these first blocks or chunks. So loading up what we'll need. And importantly, we have ggplot2. And we're reading in this cal and virus screen data and doing a bit of filtering. So it looks like we're selecting just a couple of counties. If we had plotted all the California counties, eventually maybe that's a little bit too busy. So maybe we want to narrow it in on a couple that we're interested in. Okay. So yeah, a little bit smaller data set. All right. So I just ran those chunks, but let's take a look at this question. We'll use ggplot to make a plot of how diesel particulate concentration, so it's this diesel PM column, on the y-axis is associated with traffic density values, traffic on the x-axis. We could use a lines layer, a points layer, or both. All right, let's give us a moment to think about that. All right, so we know we're going to use the ggplot function to make some plots. And again, this is really powerful, as Carrie was talking about. So first thing we want to give it, we could pipe with ggplot, but I tend to be in a habit of not doing that. It's really up to you whether you prefer to use the pipe or not. But we'll want to supply that data set either first and then pipe, or the first thing inside the parentheses. So what is our data set? It is CES sub. So let's use that. And then we have to tell it exactly what we want those axes to be, right? And it's kind of funky in ggplot. This AES part here is going to be like a flag telling you there's some kind of formula. You're not explicitly saying that all of the values on the x-axis should be, a hard-coded value. You're saying use the column of the data set and figure it out. So we're saying, all right, ggplot, I want you to look inside the data, and I want you to pull out this column traffic for the x-axis, and I want you to take a look and pull out the diesel EM column for the y-axis. All right. So very nice. Looks like it didn't create any errors with my syntax here, but this is not really the most interesting plot. It does give me the kind of the magnitude on the axes, but we're going to need to add some some geoms to get some stuff on the plot, right? We want to put, like, we've got the cake base, but now we want some sprinkles and some fun stuff, right? So let's start with geom point. Okay. And remember, I had that nice little plus sign there. All right. So that makes sense. I mean, particulate matter goes up the more traffic there is. I think kind of a little bit of a rough positive correlation or something like that going on. But just giving me a chance to kind of look at the scatter of the data. Let's see how many. Got 4 to do. Okay. And I could also add a line if I wanted to. And we're not really tracking things through time, so probably geom point makes more sense. All right. So we're going to want to update this. Oh, whoops. We wanted to actually assign it to my plot, didn't we? Whoops. Let's do my plot. So I'm going to save it. And then anytime I get rid of that, anytime I just type in my plot to the console or run some code, it'll prompt that plot for me. And again, your settings might be a little different. You might see the plot right under the chunk here. That's not wrong. It's just different RStudio settings. All right. So we want to update the plot. So the nice thing is if you created a ggplot object, we can see it's a very elaborate list here if we kind of peek into it, which is all the like parameters for the plot. If we created a ggplot object, it's fairly straightforward to just continue to tack on stuff to the plot. Okay. And we're going to want to change the title, the X and the Y axis. We can use the labs function for that, or the labs aesthetic. Let's see, as I'm typing it in, it comes from ggplot. It says modify axis, legend, plot labels, all that good stuff. So let's say our title is, and I'm going to want to use quotes here, traffic and diesel particulate matter relationship. Our X axis might be, let's maybe be more specific. We could go up here and say traffic density, get really wordy here. And then Y could be, all right, let's see what that looks like. And we'll want to update my plot and then maybe visualize it by just running that object. All right. And I can kind of adjust the figure a little bit by dragging that around. Can also zoom in, which I like. It's going to give you a little bit more high resolution, smaller font, things like that, especially if you have a very complicated plot. That can be helpful. And maybe I decide I don't like this title. I could just cut it down, try again. Okay. Any questions about kind of what we've plotted so far? Hopefully yours looks a little something like this. You might have different titles. Maybe you have the lines instead of the points. But let's try to diagnose if we're having any issues. Okay. Got 1 thumbs up. I love to see it. I agree. I think ggplot's pretty cool. I won't lie and say that I didn't spend some of grad school kind of making ggplots a little bit fancier than I needed to because it was more fun than doing lab work. That's awesome. I agree. I think it's really fun. Unless you find something really, like you do some statistics and you find something really unexpected. I feel like that's pretty fun too, but it's a little more unlikely. All right, we've got the plots. So I think in the next couple of questions, it'll be the really fun part of, changing the color schemes and doing that kind of thing. And, now that we have a plot to build off of, you could even go back to a skis and, see, you know how to change the colors around pretty quickly in there. And maybe you could copy the code and then add it on to my plot. So it can be a great way to jog your memory, especially if, for example, you're stuck working on this stuff without an internet connection. You can't Google it or the documentation's not making sense. Skis can be a nice way to get that code going for you. So we can continue adding on here. We'll use the scale x continuous function to plot the x-axis with the following breaks. Maybe we want to get a little bit more nitty gritty here and go by 250 instead of 500. I'll kind of try to leave this up here a little bit. I love this too about like the object preview. It's got this kind of like confetti look to it for a list. I think that's fun. Okay, well, let's get into this a little. So we'll update the plot. So just set that up already. But we'll want to use scale x continuous. And we want to use that because if we're taking a look at values used in the x-axis. I could even kind of explore the data a little bit and go all the way over to traffic. It's not going to filter the records there or the column names there for me. Where are we? So they are numbers, right? So it's not categorical like county or something like that. So I'm going to use continuous. All right. And if I supply more than one value for breaks, I'm going to need to provide a vector. So that means I need the C to combine values. And then I can just list out whatever I want those breaks to be. If I did something like this and ran that code, I would only have those 2 breaks. But I want to get a little bit more in there, copying those breaks that I just did. And the number's hanging off the edge a little bit. So maybe not the best. I could probably drop that one. I think that would be fine. All right. And, we learned way back when we learned the seek function. And so maybe I would want to do seek 0 to 2000 by 100, maybe. That's going to give us this, right? It's going to make a nice vector for us. So what I could do is save this as a object, that vector, and I could actually use that as a variable. We're getting fancy here. It's a little cluttered, but maybe we could update it here and kind of customize our plot that way. All right, questions about adding those breaks using scale X continuous. And again, there's just a lot of customization you can do. Breaks is just one of the options for telling your plot how you want it to look. So limits, labels, transformations, there's just tons that you can do. And you can see examples. Typically, they'll have some in there. All right. And finally, let's observe several different variations or versions of the plot by displaying my plot while adding a different theme to it. And don't worry about reassigning it, maybe just adding on one of these theme functions. It's kind of like tacking on a whole bunch of parameters at once. So you can think of it like a mega function here. So theme, and then I like to do this. So I'll type in theme underscore, and then you can just kind of scroll around for the defaults. There are more you can install for sure, but I'm a big fan of classic. BW is really nice. And then sometimes I'll use void if I am going to add in like custom labeling. Maybe it's for like a PowerPoint or something that I'm doing a talk. Sometimes I'll do that. Minimal is nice. So maybe give a couple of those a try, and then we'll look at them together. Okie dokie. Let's take a look. So let's try BW first for black and white, just meant to be pretty simple. And I do want to, So the nice thing too is if you save as a PNG image. So let's just say I'm putting that in the project folder, and I can see that plot's there now. And I open it. I want to say that there is a way to make it so that the background is transparent, and I think you may have to export. We'll see how to do that in a bit, but how you can export it using code. I believe that will save it with a transparent background. So maybe if we do like this, it might just be the theme itself. It's classic. Okay, so this is classic. I feel like this looks like an old-timey journal publication. Yeah, I think we'll have to save it using the code, but you can make it so that there's a transparent background. If, for example, you want to have like different color slides or something, not just white slides, you can do that. Also do, like I said, theme void. I just want the points. It's not maybe you could paste it and then forget what the axes were, and you don't want to be misleading, right? Like you want to make sure that you're very clear about what you're communicating, but sometimes you need it for doing animations or something like that.
We're going to move on to the second half of data visualization. There's only 2 halves. So we're going to talk a little bit more deeply about the theme function, which ends up being a pretty important function, and it's a little confusing. I think that looking at the documentation is extremely helpful for this one. So here I pulled up the documentation using $theme. I could also look it up in the help pane with the viewer here, or search tool. And I can see that there's a lot of arguments that I can include. I mean, just a ton. And they do various things to the plot. And I would say that going to the examples is probably one of the most easiest things. But if there's a specific thing we want to change, I recommend looking at the documentation. But the examples will show this sort of format that we need to use that's a little bit different from things we've seen before. But so that aspect is, you'll notice that we have inside the theme function, we are specifying an argument, one of the attributes that we're changing, which is one of the things in that giant list at the top. And then we have to use some sort of element to specify things that we want to change. And so there are only a few of these. One of them is element text. So if we're trying to change the text, we would do so using that. So here, if I wanted to change the size of the title, I can use element text for the plot title within the theme function. So we're going to break this down a little bit because I know it's a little strange, but the cool thing here is we've made a really big title, and it's nice to be able to change things like the font. So again, you can use this trick to see all the different things that we can change. And there's a lot of different options here. And then we can see the basic things that we might be able to change: element line, rect, text, title. So these are the main ones that we're going to use. Element blank is another one to help us get rid of things. But typically element text, line, and rectangle will cover everything that you would need. And then you can change all of these different attributes for each of these things. So these different components like text, size, color, fill, face, etc., they can go in the element text for plot title or axis X title. So we'll see some examples of that. But here in this last example, it was element text that was being used, which makes sense. The text that we're changing. So we wouldn't want to use ggplot or rectangle or blank because what we want to change is the text. And then we put the size here. We'll walk through some more examples, but this is one of the trickier parts of ggplot2. All right. So here we've decided we want to adjust the title to be centered, and we can do that within the theme function. All we've adjusted here for this plot is adding this component right here, which is the horizontal justification. And so it goes from 0 to 1. So if we want it to be completely in the middle, we would want 0.5. And that's kind of buried rather deeply into the documentation. So I think if you ever find yourself in a situation where you want to change the appearance of the title, coming to our slides is a good option. All right. So let's say I also want to change my axis titles. Well, I could come into theme and see, do I have anything about axis titles? Yes, I do. So in this case, this is going to be all titles. If I specify a particular one like X or Y, I would do that like this. Otherwise, this is going to cover both X and Y. And I, again, need element text because that's what I'm working with. And I'm going to change the size to be 16. So now I'm making my axis titles much larger as well. So this is what they looked like before, and now they're much bigger. There's this extremely helpful cheat sheet about the theme elements. So I highly recommend using this and keeping this, close so that you can help yourself with that. We can see here what we can do for element text, which is we can change the size of the text, we can change the color, the font family, etc. For line, we can change line type, color. It gives examples of what kind of line types we can use. For element rectangle, we can change the size, color, fill, and element blank is just for removing things. All right. And then we can see all the various pieces that can be changed in our plot. So just wanted to make you aware of that. If you had customizations that you wanted to do like that, it's the theme function that's going to help you do it. But I would recommend going through the documentation or using examples when you need to do something like that, using examples of plots that look the way that you like, which you could use our slides for. So let's start back with our data. Remember we had this weird plot that kept showing up that we didn't really like, right? Notice that it's got, I don't know about you, but I can't really interpret what's going on here. I can't tell if the value at this point in time was up here or down here. It's strange. I'm not quite sure how to differentiate the different counties. And that's because I don't have any information about county here. So anytime you get this sawtooth look and you're like, what the heck is that? Then it means you need to add color or something called group. So we could add a group aesthetic and map that to county. And in this case, it'll separate out different county lines, but they will not be colored. However, I think using color is much more useful because I can get an indicator of which one is which. But you might have a situation where you have to use black and white or something, and then you could label the lines as well. But here we've added color, and that's also solved the problem. And we have used our theme function and the legend position. If I scroll down here, I'll see legend position is an option. And there are a few things I can do. I can do bottom, top, right, and left, or none. Again, that cheat sheet would be really helpful for that. All right, so that's just to give you a sense of what's possible with ggplot. And now let's talk about some tips for challenges that you might encounter. So there is a distinction between the color aesthetic and a fill aesthetic. So we have been talking about using color here, but if we're using something like box plots or bars, we're actually going to want to use fill, likely. If we use fill, it will color in the whole box or bar or column. If we just use color, it's going to only outline the box plot, which may be what you want, but typically we want to fill in the color there. If you do box plots, we recommend adding a geom jitter layer. And this can allow you to actually point the points on top of your box plot, which is really good practice so that people can see the spread of your values. You might want to specify a width with the width argument, because sometimes the default is kind of broad and the points will be a little bit too wide. A significant number of people will have challenges seeing different types of colors. And so there are some really useful functions to help us deal with that. There's the scale, fill, viridis, D for discrete or categorical data, and C for continuous data. So if we wanted to color categorical data like these counties, we would want to use the discrete option here. And all we have to do is just add this layer and leave this open. We don't need to put anything into our function here. I'm going to show you an example. And, you can always play around. Like if you run this and you're like, oh, in this case, I don't have this data. I have a different plot here. But you can be like, oh, I think I used the wrong, it should be scale fill and paradise D versus C, just try it out. So in this case, I have continuous data. I'm going to add scale fill paradise, and I'm going to use continuous. I don't have fill though, so I'd actually have to use a different paradise function. I also only have one color here. This is hard because I can't adjust my plot because I lost my data, but you get my point. Is it would be just simply added like that. We'll show you how to do that for a scatter plot on Slack. Okay, but here we can see what happens if we try to use geom call to make a column plot. And we wanted to point out here that you can pipe your data into your plot. So say you wanted to do lots of wrangling things with your data. You wanted to group by and summarize and make a plot of the summarized data, not the raw data itself. You can use all the functions we've been learning and pipe that directly into ggplot. You just need to remember that you need to switch to that plus sign when you're doing your actual plot itself. And here we're also using scale, fill, viridis, D for discrete, and fill because we're actually filling. And we can see that it's the geom call function this time. So that's why we have this plot, this column plot here. Notice we don't have a lot of information for Jackson. That's just because the values are really low. So you can see that Jackson was really low the whole time. It's a lot easier to see it with these other plots. Sometimes it's nice to add that aesthetic outside. So remember, AES is where we're going to do the mapping to a particular variable. If you like having that outline on your geom column plots, you can add this just to that layer, and that'll add this nice black outline if you like that. You may have noticed that we have geom bar and geom call. Geom bar is only going to take one axis, whereas geom column takes two. So if you run into issues with that, that's a common problem. You just might need a different geom to use. Most importantly, though, you should note that you're not necessarily plotting what you think you are. You should always check that the plot makes sense. So here we're looking at the ER visits data, and we're seeing that we have, it's saying 400 visits for Denver, Pueblo, and Weld. And does that match what we're seeing if we were trying to map the average? Does that match what we've seen in our other plots? So the rates here are never really much more than like 25, 27, and we're showing 400. So what exactly have we plotted here? Again, here, the max rate, it's like, I don't know, 27 here. Here it's 300 something. So what do we think we've plotted here? It's a tricky one. So we haven't plotted the mean. We've actually plotted the sum of every value for that particular county altogether. And, that might be what we want, but it might not be. So it's a good idea to take a look at our data, make sure that if we're trying to do a particular year, do the values actually match? And indeed, if we look at the sum, if we summarize the data for the sum of the visits, we'll see that what we plotted matches what we saw there. So what we ended up plotting was not the average, which might be what we intuit the plot to plot, but we plotted the sum of all visits for each of the counties. So all we did was geom col, and we might expect it to do the mean, but it's going to do the sum. So just be careful. Make sure you're checking if the values match what you expect. So if we wanted the mean, we'd have to actually summarize it to get the mean using the summarize function. And the mean function, remember, in summarize, what we call our column is arbitrary, whatever we want. And we're doing the mean of the visit, and na.remove equals true, or capital T is fine as well. And now we can see, that makes a lot more sense. And we could plot this summarized data by piping that into the same code. So the ggplot code has not changed, but we are summarizing the data first. Also, it's good practice to make sure that your plots don't have really small text. That can make it really hard for people to read. So if you want to change the text of everything all at once, you can simply use the text element of the theme function and then say element underscore text size equals whatever size appears to look appropriate. So looking over here, we can see that, there's a lot of different pieces of text that we could specify, like an axis title or a specific axis title, but we can also just do all text. Also, sometimes we'll have situations where we have just way too many lines. We end up with a really busy plot. So this is not so bad, but here now we have 9 counties. So we've filtered for even more counties here, and we've plotted the same data in the same way here, geom line and coloring for county. But this looks hard for me to interpret. I can kind of still get it, but this green here is really similar to that green. So I can't really tell which one's Jefferson and which one's Larimer. So I would want to make this a little bit different. And the way that we can do that is with the facet grid function and facet wrap. So facet grid creates a grid. Facet wrap is a little more flexible. And it's going to do something really cool. It's going to split up our plots. So here we have the name of our plot, and we are asking we're just adding a layer to facet it by a particular variable. So we'll need to do a tilde inside, and it's kind of like our case when function. And then in this case, we'll often want to get rid of our legend because we don't need it anymore. So when we do that, we get something like this. So we have split up each of those lines into their own plots, and each plot has the information about which county it came from. So we no longer need that legend, so we can remove the legend, and I think it looks quite nice. It's much easier for me to tell the difference between these two counties, and I can tell that Jefferson was had a lower rate. Also, it would be really hard to see Jackson and San Juan because they would have been perfectly overlapping, but now I can see them. Facet wrap is a little more flexible. We can specify the number of columns or the number of rows. And so it'll stack plots on top of each other in this way. And we can also use an argument scales equals free, which can enable each of the y-axes to be different. So notice how the y-axis is changing from each of these plots, whereas in this one, in the grid option, they have to be the same. In this case, I think that the grid option is the best for best practices, but it depends on your data. There will be situations where you have a really high difference in range and you can't see the values. And we're not really trying to compare the different facets. We're trying to see the change in the data over time, for example, for each facet. And then in that case, we would probably want to use the scales equals free argument, which is only possible with facet wrap. And I can, specify different things. I could say number column equals 1, and I will have a single column and they're all lined up together. It just changes the way that the plots are distributed. Finally, just a couple of things here that can help us do really fancy stuff. There's a package called Plotly. It's not part of the tidyverse. So you would have to install it separately and load it library. And then all you have to do is use the ggplot2 function around the name of a plot, and it makes your plot interactive. That's it. Just one line of code around your plot object. And check this out. I can see all the information for that particular point. It's telling me that this is from El Pueblo County. The rate is 23. The year is 2016. This can be really useful if I have way too many lines or just a really complicated plot and I want people to be able to see things, or I just want it to be cool and interactive. I also wanted you to know that there's a package called Patchwork that can help you combine multiple plots together. And it basically just uses mathematical notation. So you can use addition and division essentially to stack your plots on top of one another or next to one another. So check that out if that's something you need. Finally, we're going to just cover how we can save our plots because that's an important piece. So there are a few ways that we can do this. So we've talked about how we can see plots in our plot pane. So here, sometimes we have to type it in the console for it to show up, but here I can see it in my plot pane. If I click the zoom button, I can see another window where I can adjust it to the size that I want. And then I can right click and copy that and put it somewhere. Or I can click this export button and I can save it as different types of files, or also copy it to the clipboard. So either of those options works, or I can use code and I would use the gsave function. And there's a few things I would need to do. I would need to specify a file that it's going to be saved in and what it's going to be called. And it's going to put it, directly in the working directory that I'm working in. And then I have to specify the name of the plot object. And if I want to, I can specify the height and width to change the size of the plot. And it's by default going to do it in inches. Okay, so gut check. How do we make sure that plots are filled with color instead of just having color on the outside border? Do we use the fill argument in the AES specification, or do we use the color argument in the geom box plot layer? So just for deeper understanding, would we put the color here with fill? Would we use fill equals something, so we're using a box plot, or would we put the color in the geom layer? Yeah, so the answer is indeed fill. We need to use the fill argument. So often we've used color for lines or points, but when we want to fill in the color of something, we need to use the fill argument, and we do that in the AES specification. So in that AES function that's inside the ggplot function. If our plot is too complicated to read, what option might be good to fix that? Should we add more theme layers, or should we use facet grid to split up the plot? Right. Facet grid or even facet wrap would be a great option. Okay, so in summary, the theme function helps us specify even more customizations for our plot. We recommend looking at the documentation, especially checking out that cheat sheet. It can do things like remove a legend. It can change our font to have a different text size. We have to use various elements like element text to do so. It can also help us to center a title. And if we ever forget those, we can always come back to the slides and, just take this from it, because that's going to work for every plot. And just add that layer to our plot and it'll make our title centered. Sometimes we need to add a group element if our plot looks sawtoothed, or we need to add color. And that might even be a fill, right? If we're using some sort of box plot, but a sawtooth is going to happen if we're looking at our line plots, then we might want to do that. Make sure that you always check your plot numbers. Do they make sense? Does it match what you're seeing in the data, or did something happen and things are not quite what you expected? Facet grid and facet wrap can help us quickly split up our plot if we have too many things going on. And facet wrap is the one that allows for the scales free argument, so you can have different axes scales on the y-axis. And just a reminder, if you want to fill in box plots, use the fill option and not the color. We have information about good practice for plots. How do you make plots that don't distort values? How do you make plots that are visually appealing, that people can easily understand? And we have one more session for the lab here, but also our cheat sheets about the major functions here and the posit theme cheat sheet.
Remember, we were using this kind of like subset here. All right, let's do a little bit of setup here. So we're going to want to start with that ggplot function and then supply the data. And then we want to tell it those aesthetics, the X, the Y, and then any kind of relevant grouping we might have with AES. So X would be, we said traffic, right? Y is the diesel PM. And then color is the California County column. All right. So again, that's going to just give us the naked plot. We want to add some excitement to it. So let's add geom point. Ooh, very exciting. We now have all of our points from before, but colored by county. So remember, we had kind of like this plot before, but, I have no idea where those individual points came from. Now, maybe in case I was interested in seeing, any differences, maybe some counties are a little bit more exposed to particulate matter or something like that. I might want to try to tease apart some of those differences, or at least try to observe them a little bit. Okay. Next, we're going to want to add a faceting feature to the plot. So let's actually save this and let's do my plot. We'll want to add something to it. So let's add facet wrap. We'll do as a function of California County. Let's see what that gives us. All right. I think it's already set up with 3 columns, but can't hurt to add that. All right. And if I wanted to customize this to just kind of change the shape of the plot a little bit, same data, just presented a little bit differently, depending on kind of the distribution of points you have. You may want to do something different or choose one or the other. All right. And so what's going to happen if we start playing around with whether they have geom line or geom point? I could add geom line here. And notice when I did that, it not only changed the plots, but it changed the legend too, right? And I can override those aesthetics if I want. So if I'm just saying, I ignore the aesthetics, I want all lines to be black, but the points should follow the different counties. You can do that as well. And something to remember is that ggplot works in sequential order. So if you want the points nestled underneath the line, put it first, right? Because it'll do that, then the line. But if you want the points on top, maybe put that after. So there we go. We can kind of set them on top of the line instead of under the line. So the order you supply things matters. So if we just do this, we had already supplied the points right at the beginning. Right. Questions about the ggplot stuff especially with the color aesthetic, the grouping? Yeah. So there's also another function, geom smooth, you might be interested in. We can bring up the page for that here. So that can add basically trend lines and things like that if you're interested in it. See if we have any examples we can pull up. All right. Let's go back to this plot. We'll stick another one down here and geom point. Let's do that. Okay. And then actually, I'm going to get rid of the category. So we've got a relationship, but we might be interested in a trend line. So definitely possibility. I like to have the points and the line on there. Go back to the help and they kind of give you some tips on things. You can take away the standard error and control like how wiggly the line is. So something like standard error is false. We're getting rid of the error line and using this like span argument here. It's 2.9b. All right. Any final questions before we head back? Yeah, so R tools is a specific kind of thing for Windows machines. And let me drop in the chat we have a resource for installing that. It's just like an additional thing that Windows machines need sometimes. I think that may be what's happening. So maybe if you go through that and then like restart R and then try to install that package again, hopefully that'll work. All right. Well, any other questions before we transition away from visualization? I know it's really fun. I want to keep doing it, but we're going to learn about something really helpful for making really good visualizations in the next part. And obviously the ggplot code, there's a lot to remember here, right? And even just like the help page for just one of these geoms, like there's a lot here. There's a lot that can be done. So if you ever get overwhelmed with ggplot, just encourage you to, Google for kind of what you're looking for in particular, get some pieces of code to start with, and then start modifying it, or use a skis, right? So don't feel like you gotta be able to recall all this from memory. ggplot is one of those things that you kind of iterate on and add to, once you finally got the plot you want. So don't be too intimidated if this is new to you. I promise it will get easier.